NFPA 850, which stands for the Standard for Fire Protection of Electric Generating Plants and High Voltage Direct Current Converter Stations, addresses the minimum spacing requirements between an oil-filled transformer and a combustible building. This standard is designed to minimize the risk of fire spread and protect property and personnel. The specific spacing requirements outlined in NFPA 850 depend on several factors, including firstly, the size and oil capacity of the transformer, secondly, the type of combustible building material, and thirdly, any fire protection measures that are in place. It's important to note that the requirements given are minimums, and it is up to the engineer to determine if more spacing is required. NFPA 850 provides detailed tables and guidelines for determining the appropriate spacing. For example, a large transformer with a significant oil capacity will require greater separation than a smaller transformer. The type of wall construction of the building is also a large factor. A building with concrete walls will not require as much spacing as a building with wood walls. Also, the inclusion of fire-rated walls may also affect spacing. In addition to the spacing requirements, NFPA 850 also addresses other fire protection measures for oil-filled transformers, such as fire suppression systems, containment systems for oil spills, and fire-resistant barriers. These measures can help to reduce the risk of fire and limit the damage if a fire does occur. NFPA 850 is a comprehensive standard that provides detailed guidance on fire protection for electrical generating plants and high-voltage direct current converter stations. It is important for engineers, designers, and installers to be familiar with this standard in order to ensure the safety of these facilities. The information in the standard is based on the most recent industry data. Regular reviews and updates ensure the standard remains accurate and appropriate. NFPA 850 is updated regularly to reflect the latest technological advancements, research findings, and best practices in fire protection. These updates ensure that the standard remains relevant and effective in addressing the evolving challenges of fire safety in electrical generating plants and high-voltage direct current converter stations. When designing and installing oil-filled transformers, it's essential to consult the latest edition of NFPA 850. This will ensure that the installation complies with the most current safety standards and best practices. It is critical to understand the importance of proper documentation and record keeping. All aspects of the fire protection design, including the spacing calculations, fire suppression systems, and containment measures, should be thoroughly documented and maintained. This documentation is essential for demonstrating compliance with NFPA 850 and for facilitating future inspections and maintenance activities. NFPA 850 requires regular inspections and maintenance of fire protection systems and equipment. These inspections should be conducted by qualified personnel and should include a thorough assessment of the condition and functionality of all fire protection measures. Any deficiencies or problems identified during inspection should be promptly addressed and corrected. Proper training and qualification of personnel are essential for ensuring the effective implementation of NFPA 850. Personnel involved in the design, installation, operation, and maintenance of oil-filled transformers and fire protection systems should receive adequate training on the requirements of the standard and the specific procedures for their roles. It is important to remember that NFPA 850 provides guidance on the minimum requirements for fire protection. In some cases, it may be necessary to implement additional fire protection measures to address specific hazards or to meet the requirements of local codes and regulations. A thorough fire hazard analysis should be conducted to identify any unique risks associated with the installation and to determine the appropriate level of fire protection. The fire hazard analysis should consider factors such as the type and quantity of combustible materials present, the potential ignition sources, and the consequences of a fire. Based on the results of the fire hazard analysis, additional fire protection measures may be implemented, such as increasing the spacing between transformers and combustible buildings, providing additional fire suppression systems, or installing fire-resistant barriers. The information from NFPA 850 is applicable in a wide range of settings, from large power plants to smaller substations. Regardless of the size or complexity of the facility, the principles of fire protection outlined in NFPA 850 remain essential for ensuring the safety of personnel and the protection of property. Consulting with fire protection engineers and other experts can provide valuable assistance in interpreting and applying the requirements of NFPA 850. These experts can help to assess the fire hazards associated with specific installations and to develop customized fire protection solutions that meet the unique needs of the facility. It is imperative to stay informed about any updates or revisions to NFPA 850. The standard is periodically revised to reflect new technologies, research findings, and best practices. Staying current with these changes is essential for ensuring that fire protection measures remain effective and compliant with the latest requirements. Compliance with NFPA 850 is not only a matter of safety, but also a matter of legal and regulatory compliance. Many jurisdictions have adopted NFPA 850 as a mandatory code or standard, and failure to comply can result in fines, penalties, or other enforcement actions. In addition to the direct costs associated with non-compliance, there are also indirect costs, such as damage to reputation and potential liability for damages caused by a fire. When selecting fire suppression systems for oil-filled transformers, it is important to consider the specific characteristics of the transformer and the potential fire hazards. Different types of fire suppression systems are available, each with its own advantages and disadvantages. Some common types of fire suppression systems include water spray systems, foam systems, and gaseous fire suppression systems. Water spray systems are effective for cooling the transformer and suppressing flames, but they can also damage the transformer and electrical equipment. Foam systems are effective for smothering the fire and preventing reignition, but they can also be messy and difficult to clean up. Gaseous fire suppression systems are clean and non-conductive, but they can be expensive and may not be suitable for all applications. Containment systems for oil spills are an important component of fire protection for oil-filled transformers. These systems are designed to contain any oil that may leak or spill from the transformer, preventing it from spreading and creating a fire hazard. Containment systems can include dikes, walls, or other barriers that surround the transformer, as well as drainage systems that collect and remove spilled oil. The design and construction of containment systems should comply with applicable environmental regulations and industry best practices. Fire-resistant barriers are another important fire protection measure for oil-filled transformers. These barriers are designed to prevent the spread of fire from the transformer to adjacent buildings or equipment. Fire-resistant barriers can include walls, roofs, or other structural elements that are constructed of fire-resistant materials. The fire resistance rating of the barrier should be appropriate for the potential fire hazards. In addition to the specific requirements for oil-filled transformers, NFPA 850 also includes general requirements for fire protection in electrical generating plants and high-voltage direct current converter stations. These requirements address a wide range of fire hazards, including electrical hazards, flammable liquids, and combustible materials. The general requirements of NFPA 850 should be considered in conjunction with the specific requirements for oil-filled transformers to ensure comprehensive fire protection. It's beneficial to perform regular fire drills and training exercises. Fire drills and training exercises can help to ensure that personnel are familiar with fire safety procedures and that they can respond effectively in the event of a fire. Fire drills should be conducted at least annually and should involve all personnel who may be involved in fire response. Training exercises should cover topics such as fire prevention, fire detection, fire suppression, and evacuation procedures. Establishing and maintaining a fire prevention program is a proactive approach. A fire prevention program can help to reduce the risk of fire by identifying and addressing potential fire hazards before they cause a fire. A fire prevention program should include regular inspections, maintenance, and housekeeping activities. It should also include employee training on fire safety and fire prevention. A thorough understanding of the properties of oil is important. Oil-filled transformers use oil as a coolant and insulator. The oil is typically a mineral oil or a synthetic oil. It is important to understand the properties of the oil, such as its flash point, fire point, and auto-ignition temperature. This information can help to assess the fire hazards associated with the oil and to select appropriate fire protection measures. Ensure that you are following all applicable codes and regulations. In addition to NFPA 850, there may be other applicable codes and regulations that govern the fire protection of oil-filled transformers. These codes and regulations may be federal, state, or local. It is important to be familiar with all applicable codes and regulations and to ensure that the installation complies with these requirements. The documentation and record-keeping requirements outlined in NFPA 850 are critical for demonstrating compliance and facilitating inspections. These records should include information on the design, installation, testing, and maintenance of fire protection systems. They should also include records of fire drills, training exercises, and fire prevention activities. These records should be maintained in a secure location and should be readily available for review by inspectors. By implementing these fire protection measures and following the requirements of NFPA 850, you can significantly reduce the risk of fire and protect property and personnel from the devastating consequences of a fire. Understanding the fire behavior and spread is crucial in mitigating risks associated with oil-filled transformers. Fire behavior refers to how a fire starts, grows, and spreads, while fire spread refers to how fire moves from one area to another. Understanding these concepts can help in designing fire protection measures that are effective in preventing and suppressing fires. The arrangement and layout of the transformer and surrounding equipment can affect fire spread. Proper spacing between transformers and other equipment can prevent fire from spreading rapidly. Also, the use of fire-resistant barriers can prevent fire from spreading to adjacent areas. Understanding the available fire protection technologies is essential for selecting the right systems for the specific application. Fire protection technologies include fire detection systems, fire suppression systems, and fire containment systems. Fire detection systems are used to detect the presence of a fire and to alert personnel. Fire suppression systems are used to extinguish a fire or to control its spread. Fire containment systems are used to prevent fire from spreading to adjacent areas. The design and maintenance of electrical systems can affect the risk of fire. Poorly designed or maintained electrical systems can be a source of ignition for fires. Regular inspections and maintenance of electrical systems can help to identify and correct potential fire hazards. The importance of emergency response planning and preparedness is paramount. Emergency response planning and preparedness are essential for ensuring that personnel can respond effectively in the event of a fire. Emergency response plans should include procedures for evacuation, fire suppression, and first aid. The plans should be regularly reviewed and updated to ensure that they are effective. Training exercises should be conducted to familiarize personnel with the plans. The role of human factors in fire safety is an important consideration. Human factors refer to the human element in fire safety, such as human error, complacency, and lack of training. Human factors can contribute to the cause of fires and can also affect the effectiveness of fire protection measures. Addressing human factors through training, education, and awareness programs can help to reduce the risk of fire. The importance of continuous improvement in fire safety practices should be emphasized. Continuous improvement involves regularly reviewing and evaluating fire safety practices and identifying areas for improvement. This can involve implementing new technologies, updating procedures, and providing additional training. Continuous improvement is essential for ensuring that fire safety practices remain effective and up to date. Remember, adherence to these guidelines significantly minimizes fire hazards and promotes a safer operational environment.